My name's Professor David Lary, and I'm here with a team from the University of Texas at Dallas in the Hansen Center for Space Sciences, and our group is called MINTS, which stands for Multi-Scale Intelligent, Interactive and Integrated Sensing. So what we try and do is comprehensive, holistic sensing of the environment from micro scales to the global scale, using a whole array of sentinels, from satellites, robotic vehicles. We have sensors across cities recording 24/7. So we try and comprehensively characterize the environment. Today our exercise was to demonstrate an autonomous robot system that can rapidly, much quicker than the existing systems that we know of, to gather data, to then use machine learning to provide comprehensive maps of an environment that maybe you've never seen before. So our robot team here had two robots. So one part of that was the aerial robot. So the aerial robot was carrying underneath it both a hyper-spectral camera measuring these 462 wavelengths from the ultraviolet to the near infrared. It also had a thermal camera. The thermal camera can be useful for a whole range of things, and also a visible camera. So we had pre-programmed with our autonomous control software exactly the area we wanted the vehicle to survey. And in fact, in just over 3 minutes, it surveyed that entire area, and it took off automatically, it flew automatically, and it can also land automatically. And while it was flying, it was capturing this hyperspectral imagery, the thermal imagery, and the regular visible imagery. Now, the reason it's significant that we had a regular visible camera is that we're also investigating something called super resolution. So you're probably familiar, like in a CSI movie, there's an obscured car tag and you can't see it, and they auto-magically suddenly zoom in. So we're working on that same type of technology, but instead of just doing it for enhancing the spatial resolution, we're investigating going from using a regular visible camera to the much more detailed information of a hyperspectral camera. So the second part of the team that operated today was the robotic boat. So you can think of the robotic boat as giving us the ground truth. So we can rapidly survey a large area with the aerial vehicle and capture imagery, but we really need to know, what does that imagery correspond to? What do those spectra actually mean? So the boat was laden with a set of sensors, about 30 sensors in fact, a whole array, a sonar giving us the depth and the bottom type, the type of vegetation growth, and then a whole set of composition sensors, things like algae, oils, and we can also have a mass spectrometer that can measure all the components of the water and the air. So the boat goes out and directly sails underneath where the aerial vehicle was flying. So that precisely coordinated element is critical, because that allows us to rapidly get the relevant coincidences. So when NASA does this, and I was part of doing that when I worked there, you actually have these happenstance overpasses. You have a satellite in a fixed orbit that happens to overfly your scene of interest, your scientific cruise, or whatever else is making the measurements. Here, we very rapidly get a massive data volume because the robotic team knows what the other robot is doing, and in a precisely coordinated way measures at just the locations required. So I'll give you a specific example. Hurricane Harvey made landfall in Lockport. In Houston, we have these huge oil refineries and other Superfund sites. Many of those chemicals went directly into the water as a result of the hurricane. Several neighborhoods were surrounded on 3 sides by that heavily contaminated water. Those chemicals were outgassing. People were having severe respiratory issues, and they had no idea what was in the water that was being released. And then the cleanup crews were going unprotected into the water, causing further issues. So we've seen we can start to address that question, is the area safe, by the comprehensive and autonomous sensing, producing these large area maps rapidly that we've spoken about. One of the things I'm really passionate about is making things usable to provide actionable insights. So take, for example, this hyperspectral camera that today we were using to look at the composition of the water. That same camera we could be using to look at the healing of wounds. And in that context, you can use that hyperspectral camera to see like the depth of the calluses there, the oxygen in the skin, and a whole range of other things that very usefully map the progress of the wound healing. One of the paradigms that we've operated on is we want everything we do to be scalable. We don't want just to have a one-off. We want to be able to build systems that we can roll out at large scale. So if it's not just one unit, supposing now it's standard issue for units in a given context, they can have this capability. It's all packed up in packing cases and out it goes. And so being able to rapidly do a survey, classify the area you've just surveyed, can help you do a much smarter real-life truth checking on the ground for where the contaminants are. It can quickly guide you to the contaminants rather than just stumbling across it by using the usual approach.